Hello, everyone. This is your trainer, Akash Sharma. I hope you guys are doing good. We'll start the session now. I can see like a lot of people have already joined in. So today we are having day 15 of this amazing training, the faculty development program in cybersecurity, right? 30 hours together. I'm pretty sure you guys learned a lot of new stuff. And we have reached the final day where we are going to learn cryptography, one of the most complex topics, but I'll try to make it easier for you to understand, and I'll make sure you guys get a hold of it and at least know the basic stuff before you guys leave, right? So let's start today's session. I'll be sharing my screen here. Okay. See, you will get theory for cryptography from literally everywhere. Okay. I'm not here for that. I'm here to tell you what is the concept and why it's really important. That's what we will discuss in today's session. I can see people are still joining in. So let's give it a couple of more minutes if that's okay. In the meanwhile, if anybody have a question, you guys can ask me as well. No problem. From either today's session or yesterday or any session for that matter. Okay, I think we can begin. We have enough people. So this word cryptography, you must have heard this a lot lately. Either this or I'm sure you must have heard of encryption at least, right? On WhatsApp, on Instagram, Twitter, you must have read this term a lot. Encryption, right? What are these things? Before we actually start understanding them, let's understand a simple authentication process. Consider This is your browser. You're logged into a website xyz.com, right? And of course, you are connecting with a web server, obviously. You are the user over here, and this will be the server, the WS web server. Now, when you are registering on the website, let's say it's asking you for two credentials. The username and the password, and the submit button is here, right? This takes your username, this takes your password. It passes down these two credentials to the server, and the server will store this information in the database. Correct? But what if because this is a possibility, that what if a hacker is able to access the database as well? In such kind of a scenario, your credentials are leaked, right? Because now he also have access to your username and your password. So what exactly is this web server going to do to provide you the protection that you deserve, right? What this website can do? It can provide encryption. Now let's understand what is encryption, okay? I'll go a few steps back. Right where you are on the website over here, you have your username, you have your password, okay? Now, when you move forward from your website, these details basically are in simple plain text, okay? These are in plain text. That means anybody can read it, even you, me, computers, everyone can read it, right? It's plain text information. But as soon as it leaves your system, it's about to leave your system, there is something called as an encrypting algorithm. This algorithm is basically nothing but a mathematical function. Oops, I turned on burp suit by mistake. Okay. It's a mathematical function that can, for conversion, basically, that can convert some stuff. That's an algorithm. Now, let's understand this very simply. My name is Akash. You know this by now, right? And if I make an algorithm that says every placeholder over here, there are 5 places in total, right? 1, 2, 3, 4, 5. 5 places in total. Now, every single place is denoted by X. So there's X1, X2, X3, X4, and X5, right? Everyone is denoted by X. So I create an algorithm that says, take X and perform a function where X is added by 2, and then this will be the final value, Y. Take X as a raw format, right? And in X, you add 2 in it, and then you create a final form of Y. So now when I have Akash, if I add 2 into it, A plus 2 will be C, K plus 2 will be M, C, U, J. CMCUJ. This will be the final value for X1, X2, X3, X4, and X5. You see what conversion did happen here? It was a simple mathematical function would actually converted this into this format. This is the encryption part. Okay. What if I want to decrypt it? Simple. I encrypt it with this function over here. For decryption, I'll make a simple function that says when y we decrease 2, then it becomes x. It's simple maths, right? You understand this? Because when x is added with 2, it becomes y. So if you remove 2 from y, it becomes x again, right? So if you go back 2 from here, you go back to a, k, a, s, h again, right? And that is the whole point of decryption. You see, this is how it works. Encryption and decryption both are similar concept, but complete. The concept is similar. The result is different. An encryption algorithm. Let's say I'm doing it for password right now, as of now, and the algorithm says something like this. This is the algorithm probably x plus 2. So if my password is random, okay, if this is my password, after x plus 2, it becomes this thing basically becomes a ciphertext. Oops, doesn't look good. Okay, a ciphertext is the text which is the final form after the encryption. So now after x plus 2, my password will become T C P F Q O. So this is gonna be my password. I was actually doing it in my head, so it took me a while. So it's okay, no problem. You got it. So this will be my final form, that is the ciphertext after the encryption. Now, if it is being saved in the website, this is how it will be saved. But what if this was a communication between two people? Then the story would be different, right? Oh God, what wrong? What is wrong with it? This is exactly how it is going to be saved in the website. In the database, it's not going to save random here. Instead, it will be saving this ciphertext, so that if a hacker even gets an access on the database, he will be accessing this keyword TCPFQO, right? Which is not the exact password, but this is the encrypted password, right? So if he tries this password, he will not be able to access because the actual password is random, which was just jumbled with this algorithm x plus 2, right? Now imagine the similar conversation between two people, right? Person A and is sending something to person B. Okay. Now let's see what happens here. The data at A could be something like, it could be KALI. Okay. This is what the A wants to send to B. When it leaves A, there's an encryption algorithm going on. I'm going to type ENC so that you know it's encryption. The algorithm is simple. could be x plus 3, right? It gets converted into ciphertext, as you know. And the encrypted ciphertext I'm sorry, just a second, guys. Okay, yeah, sorry for the disturbance. Okay, so the ciphertext after this conversion will be something like N D O L. So after the conversion of the ciphertext and this algorithm implementation, the final string that we get is NDOL, right? Now, this is the ciphertext in transition, so that if a hacker is somewhere in between, he won't be able to access it. But when B is a user, right? This is not a server, this is not a database. It's a normal user, right? Just like A. And if B want to use the same, he wants to read the same thing, there will be an decryption process as well. I'm going to call it DEC. That will be simple y minus 3. X plus 3 becomes y, right? Now y, when we'll be decrypting it, becomes y minus 3, so that it can be decrypted into plain text and can be delivered to B. When A types, it types in plain text as well. But in the encryption process, it gets converted into ciphertext and gets delivered to B in the plain text after the decryption process. So this is how data travels in a network in general, from one device to another device. Encryption, decryption takes place. Now the problem here is, what if the hacker knows what kind of encryption or decryption algorithm is being used? If the hacker knows it is x plus 3, then the hacker can actually, just step in between and do the same encryption and decryption. And can he also read the same passwords or read the same username, right? Now, to save from this kind of a situation, in cryptography, there is a functionality of a key. This key is very unique. This key is the most important element of cryptography. The encryption algorithm can be given to anyone, doesn't matter. The hacker may know how it is being encrypted, but he should not know how it should be decrypted, because encryption can be made public. Encryption can be made public, but decryption should always remain private. That means it should not be available to anyone else. Only A and B should be having how it is going to be decrypted, because then only the privacy will be there. They may encrypt it in any way, whatever that matters, right? But how the decryption is going to be, it's going to be always different. It's like when I'm saying something really deep, with a very deep meaning, I am encrypting information in it, but only the people who understand what I'm trying to say, they will be able to make sense out of it, right? Not everyone will understand what I'm saying because it's a very deep topic. So how you decrypt is very private. How you understand my words is very private. I might say the same thing to 3 people, but all 3 of them will understand differently, because their decryption method, their decryption algorithm is very private to them, right? Similarly, These keys also hold a very, very important value in the whole cryptography process. Now, if the same key, that is key 1 and key 1, if the same key is used to both encrypt and decrypt, okay, understand this very carefully. If the same key is used to both encrypt and decrypt, then this kind of a encryption and decryption process is called symmetric encryption. I don't know if I spelled it wrong. The double M, right? Symmetric encryption. When both same keys are being used. But if different keys are used, let's say, if it's not key 1 and if both of them are not key 1, but instead of using the same key for decryption, if I use a separate key for decryption, key 2, now this becomes asymmetric encryption. Asymmetric, because there is no symmetry for the keys. There are two different keys altogether, key 1 and key 2, different keys. When this key is actually the most important, the encryption will not take place without this key. The decryption will also not take place without this key. And these keys are stored on the end users. This key exists on the end user, this key exists on A, and this key exists on B. So the encryption on A will only proceed if the key is provided. Similarly, the decryption on B will only proceed if this key 2 is provided. If the same key is used, there is a possibility that a hacker can get access to the same key as well, right? But if two different keys are used, then it becomes more difficult for the hacker to assume that, what kind of key is being used for decryption. Encrypting process can be made public. It's simple. It doesn't matter. Even if you make it private, it's okay. If you make it public, no, even then there is no harm. But the problem is with the decryption. It should never be made public. It should always be private. And the keys should never be made public. They also should always be private on the end-to-end user. You might have heard of this thing called end-to-end encryption, right? Guess what? This is exactly how it is done. Almost exactly how it is done. Not exactly this, but this is the same kind of concept they use. The keys are always going to be private to each user. A will have its own key, B will have its own key. And they will only be able to exchange messages encryptedly. Nobody in between will be able to see what they are sending. The hacker will be useless. He will not be able to decrypt what's being sent and what's being received. Now, when I was showing you the example of a database over here, like how the data is being stored in a database, the problem is still there that if the hacker knows the encryption model, there is a problem, right? Because once this key is stored, once the ciphertext is stored, let's say the database stored TCP/FQO, okay? This is your password. Your username is admin, and this is your password random. And the database have stored the encrypted value for your username. Every time you will log in, the website will not compare random. It will see first that after the encryption, whatever value comes out, if the value is XYZ, is XYZ equal to the data I have stored or not? So this way, even if the hacker steals the database's credentials or the data which is in the database, he will still not be able to figure out the password, because database is not storing your clear password. It's just going to compare the encrypted value that is being stored along with your inputs. Your input will be encrypted and then it will be compared, right? If you remember from my previous lessons, I've shown you how the comparison works in websites, how database compares both username and password and validates accordingly. We have already seen that much information. And for an enhanced security, there is an encryption layer added over here as well. Now, this was simple encryption and decryption algorithm. Problem is that if hacker knows the encryption process as well, there is going to be no scope for security, because even if the passwords are being stored encryptedly, the hacker can still access them. The question is, what else we can do about it? So there comes a concept of something we called as hash. They are very, 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 very conceptually similar to encryption, frankly. I'll show you the difference. If A is sending a string, let's call it testing, okay? When A sends it to B, it's being sent in plain text, correct? But if I add an encryption algorithm in between over here, if I add an algorithm, I'm not calling it the encryption algorithm, but this is just an algorithm. That will scramble testing into some random stuff. Pi hash 2a 967 asterisk underscore 4. Right? If this is what being converted and being stored on B, right? Instead of B, let's consider the web server, because that was the example I was giving. If this is what is being stored on the database on B, this thing that we just generated is actually called a hash. You might think that it is almost similar as encryption, right? But if you forgot, encryptions can be reversed, right? With a decryption mechanism, encryptions can be reversed. When you talk about hashes, they are irreversible. They cannot be reversed. Once a hash is generated, it's going to be the same forever. For testing, this is the hash always. And this algorithm function is called the hash function. And the generated value we got, this value is actually called a hash. You call a digest, you call a hash value, hash, whatever you want to call it, doesn't matter. Generally, we call it a hash. If A is storing his password on this web server, if this is the password, it is going to be saved as irreversible hash on the database. So every time A will log in, the database will validate the password hash and just confirm that if it is correct or not. The hash functions are designed in such a way that if a single character is misplaced, let's say instead of this password, and if the hash that was generated was X, if I create a password like this, the hash will not be the same, it will be Y. So that means even a single character change can make a lot of difference. The hash values will never be same just because a single character changed here, you see? So it will never be the same. So that's the beauty of hashing. So, but question here arises again, what if two users are having the same password? Then what? Similar kind of hashes will be stored on the database, right? That is going to cause a hash collision. This is something that happens on databases a lot. It's called a hash collision. This happens when multiple similar hashes are being saved. What if 500 users are there and out of 500, 200 people are having the same password? Because it is possible, right? I mean, people can have similar passwords. The problem is going to be on the database and the storage. Like, how is it going to differentiate what kind of hash is being stored for which user? Because now the hashes are going to be similar, right? In that scenario, there is another as element added here, which is called as a salt. I know it sounds funny. Salts are also added to hashes to make them more, secure. Now, what will happen when A will send something like as testing to the database? Okay, what the hell am I doing here? When A sends testing to the web server, the hashing algorithm will do something funny. If A is your input, I'm going to call it INP. The algorithm here will do something strange. Along with the input, you will add some random string like ran123. Now this altogether will be hashed. So basically your final input that will be hashed will be testing ran123. If A does it, if A is going to save his password, the input that is added is ran123. But if B does the same to the web server, the input that is added over here, the additional string that is added, could be something else. If let's say the password for B was, I don't know, collect. If this was the password, the algorithm will may add something like collect plus triple 98. So this will be sent to the web server after hashing. So whatever hash it will create, it will be sent to the web server. So now, even if the both of them are going to have the same password, okay, even if B uses the same password, even if B is using testing, the hash that will be generated for B will be totally different from A because of the input that is added over here. This input and this input is different, right? So testing ran123 becomes different and testing triple 98 becomes different. So salting is when you add a random string to different users every time they are going to save the password. That is salting. This random string is a salt that is added, and the salt is always going to be different than for every single user. So even if 500 users are going to have the same password, all 500 salts will be different for them, and hence it creates a different outcome altogether. Now let me show you practical for hashing, that how hashing actually works. Okay, give me a second. I'm going to share you a lab here. Just a minute. Hashes can be created for files also. Like when you were looking at examples for virus total, if you remember, whenever I upload a file here for testing purposes to see if this is like a genuine file or not, there's a hash also associated with that file. Whenever I upload, I'll show you what I mean by that. If I upload a picture, see it generated a hash for me, and when it shows me the result, so that you see over here, this is the hash of my file. The question is how it got generated and how you can generate hashes for your files. I'll show you that. We can do it with the help of a software. It's called hash calculator. I'll show you the demo for it. You can download hashcalc from my drive. I have a tools folder there. You can download it from that tools folder. Hashcalc is over here. This is the application. This is the interface for hashcalc. Now, the data format says I can do it for a file. I can do it for a text string also. Let's say I want to convert a hash for AKASH. When I click on calculate, it will start creating hashes and different functions. I told you about the hash function over here. You see this algorithm that I was talking about. Algorithm, the hash function. There are many types of hash functions, and these are the types of hash function that are shown over here. Like MD5 is here. It's SHA-1, SHA-256, 512, RIPE MD, CRC 32. So there are different hash functions basically. Yes, Sunita, you can verify the hashes you already have. I'll tell you how. This is a string, a cache, and if I just add, if I make a capital S instead of a small s, see the hashes are different. I'm going to show you in comparison with two calculators open here. This is the one having with a capital S, and this is where I'll be calculating with normal, you know, with a smaller s. Yep. We can see hashes are different. So even a single character can actually change how the hash is going to be generated. So no two hashes will ever be the same. That is for sure. But let us just create a file quickly here. I'll create a new file, a text file. And if I name it testing, I'll open it and I'll type something random in here. This is a random file I am sending to my boss. Okay. I'll save it and I will close it. Okay. Now, this testing.txt over here is including certain kind of text that I want to send to my boss. So what I'll do is I'll upload this file in my hash calculator before sending, of course, and I will note down the hash. Testing.txt. I'll open this. You can see here, I have it. This is a complete path. And I'll calculate. Now, let's say I note down the SHA-256. I'll go for SHA-256. I note down this long hash over here. instead of this long, let's look at something smaller and simple. Let's go with MD file only. This will be a good example also. This is the MD file before sending. This is the MD5 hash. Now what I'll do is I will send this file to my boss along with this hash in the email. Okay, that this was the hash file when I sent it to you. Now in this whole process, while I was sending the file to my boss, what happened? There was a bad guy, the hacker. Wrong with my stylus. Just a second. Okay. So if I am going to send it to point B, my boss, in between, if a hacker comes in and makes some sort of changes to this file, he modifies the file. He adds maybe a malicious script or something like that. Now see what happens when even the slightest change is made. Before sending, let's say this was a hash, and when my boss received the file, and when he checked the hash for this file, it was different because the hacker have made some changes in it. You are hacked. Malicious script added. Or you don't even need to type that much stuff. Even if a single change is made, I'll save it again for you. Okay. And I'll go back in hash calculator. And now if I check one more time for the same file, by the way, just because a single change was made, the hash is totally different. You can see. Now, if the boss confirms the hash is same, then only we confirm that the file is safe to use. Otherwise, it will be considered as compromised or malicious. Because when I send, it should be received with the same hash. A file will not change its hash if it is untouched. So this is how the integrity is maintained for the file. Remember in the very beginning of the class, I told you about something called CIA, confidentiality, integrity, and availability. The integrity part is actually comparison of hashes. These can be considered as fingerprints of a file or a string. So if I already have a hash over here for a particular file, I can check with the hash calculator if the hash is still the same. If it is not same, it is confirmed that somebody have made some changes, which I'm not sure about. Otherwise, the file will always have the same hash if it is untouched. This could be for images, this could be for PDFs, documents, whatever kind of file you have, doesn't matter. So if you have sent from A to B, both people should check the hashes. If they are the same, then only the file should be considered safe. Otherwise, don't use it. Otherwise, that means there is somebody who have manipulated the file or compromised the file in one way or the other. So that is the importance of hashing. And this is how you can calculate actually with the hash calculator. It was simple, right? You can I'll add this tool in the drive in a tools folder, right? I'll create a tool folder and I'll add all the tools, all of them actually, like Wireshark, Burp tool, whatever. I'll add all of them. You can download from there also. So this was the example for hash calculator. There is also another one I want to show you. Like to keep a record, you can also use a tool called MD5 calculator. MD5 is one of the most commonly used hashing algorithm. Okay. most commonly used. I'll also add this in my tools folder. It's called the MD5 calculator. It's a little bit more better for record keeping and everything. Let's say I add this file, you know, this is like a normal file, and I'm going to save it. I'll click on add files, open this file, testing.txt. I haven't calculated the hash yet, but as soon as I click on calculate, you can see at the bottom, I got the new hash, right? So if the file is corrupted in some way or the other, the hacker might have made some changes to it. Even a single, if I add a single period at the end, it changes the integrity. You will see how what I mean by that. I'll upload the file again. Okay. I already have a hash value, MD5 value over here, but I'll again add the same file. Now you can see the values are changed. It shows in red. That means the earlier value is not the same as it was before. I can copy and compare also, but this is how you can actually confirm if both of them are the same files or not. If it's in red, that means, of course, there have been some change. So even a single dot can actually make a difference. So that's how actually MD5 works. MD5 calculator is the one of the most commonly used hashing algorithm calculator. But I frequently prefer hash calc because it's like easy to use and it's like a one-time thing, so I don't need to really save it. So it's pretty simple to use mechanism. Okay. There are many other hashing tools, but one of the best one is hash calculator. You can use that, no problem. Okay. Now we are talking about communication part. Actually, encryption can be used for your own data as well. You can encrypt your pen drives, your hard disk, your external hard disk, whatever you want, you can encrypt them as well. Let's say there is a tool actually for this, which is called as VeraCrypt, very commonly used tool and very famous one too. One of the most reliable tool, VeraCrypt. I'll show you the tutorial, and I've also saved the tutorial in your, I'll save the tool in that folder in my drive. Okay. Simple to use mechanism. First thing you do is you click on create a volume. See, as of now, I might have these many volumes in my system. Let's just click on create volume. It's asking me if I want to create a new encrypted file container or encrypt one of the already existing or non-existing one. I'll go with the first one. It creates a virtual encrypted disk. If you'll read the description here, within a file, recommended for inexperienced user. Let's understand the basic functionality of it. It creates a virtual encrypted disk. That means it is going to be in your system, but a virtually created one. Just like you are using a virtual machine, it creates a virtual disk. You'll see what I mean by that. You'll see and understand the practical once I'm done with it. Click next. Select the first one, click next. Now it asks you what kind of volume you want. If you want it hidden or standard, let's go with standard first, because that will be like a basic understanding. Then it asks you where should be your volume location, like where you want to save it. Click on select file, and let me save it on desktop. Okay. Testing.txt, save. Okay. If you'll see, this file over here that I just chose, testing.txt, will now work as a virtual container. If you'll read the description, it clearly says the VeraCrypt volume can reside in a file called the VeraCrypt container, which can reside on your hard disk. So it's like a virtual disk it will be creating. A VeraCrypt container is just like any normal file. Click select file to choose the file name, and I mean, it's just a simple file, but it will be like a virtual container. It will be like a hidden secret container. I'll show you how it will work. Just simply click next, keeping all the defaults in place. Now it's going to ask you the encryption algorithm. Because you don't know much about it, it's okay. You can just simply select the default one. Click next. Then it asks you the volume size, how much virtual size you want to make. If your hard disk is like really good enough, like 1 TB or more, you can create a bigger virtual disk also. But I'll be just giving you an example. So let's just take maybe, I don't know, 50 MB, or let's take it 20 MB. Okay, only 20 MB. So this will be enough. On my C drive, I already have 2.93 gigs. I just want 20 MB just for the sake of demonstration. Okay, click next. It's going to ask you the password to access this kind of a virtual disk, because it's a secret virtual disk. It's going to ask you password. So I'm going to type a password like maybe Poland 007 star capital A. Okay, I'll click next. Passwords are easy to crack using brute force techniques. We recommend choosing a password of 20 or more characters. They ask me to keep a really big password. Okay, you know what? They want a big password. I'll give them a big password. And I'm not going to tell you this password, of course. Okay, this is one of my emails password, by the way. I don't know if it's like more than what they expect me to type, because it's not giving me a next option. I think it's way too much bigger for them. Okay, this is better. Okay, fair enough, no problem. 20 or more character. Maximum possible length is 128 characters, but I don't know why they didn't allow me to. But okay, anyways, we have the password now, and I click next. Now it is asking me the volume format. Now this is a little bit complex to understand. It's basically the file system. How your hard disk stores your information highly depends on the kind of file system it have. Linux have a different file system, Windows have a different types of file system, Mac have a different one. So every operating system have its own way of saving in the files, own kind of format for the hard disk. I'm going to keep the fat one because it's like the default one. It is going to create a key for me. So the randomness of the key will depend on my mouse movement. So the more you see, the more mouse I'm moving, the more random it's going to create. But if I stop moving it, you see, it stopped creating a password. So the red line represents how random my password is going to be. So the more random it's going to be, the more better it will be for me. So I'm going to keep it that way. You always select the random pool, make a check mark over here. And you see the line turned yellow. So the more mouse I move, the more better it will be. Randomness collected. Now you see it's green. That shows, okay, this is a good one. The password is becoming more and more better. The more better, the more random it will be, the more better it will be to crack. I mean, the more harder it will be to crack this key. You know, this key will be stored on my system. You remember the keys I told about, key 1 and key 2. So this key will be used to decrypt all my files whenever I want to use them. So this key should be really tough to crack. So you can see the password strength have reached the maximum. Now I can really I can be relieved, and I will simply click on format. Okay. Warning. Are you sure you want to delete the file and replace it with new VeraCrypt container? Yes. I'll click on yes, and we'll, I think, start the process of the creation. Okay, VeraCrypt volume have been successfully created. Okay, fair enough. Great. Have been created, yes, ready for use. If you wish to create another, click next. Otherwise, exit. Okay, I will exit. Okay. Now, okay, hold on a second. Okay, now it's showing me a drive letter over here. Like if I have C drive already, which has already been occupied, so I can select a random drive, whatever I want. Let's say I want to select maybe any one of them. Let's go with I. Okay. And I'll select the file which I have created a container with, which is my testing.txt. It is a container that I just created. So I'll click open, like just like this. And then I'll click mount. So that's a container that I am putting on I drive. As of now, if I'll open my file manager, you see I only have this one single drive here, drive C. D is empty. E is also there, which is also occupied, but it's also like already an assigned character. So I'll choose character E for a new drive to be created, and I'll click on mount. So this will mount my container, the virtual container, on I drive. Okay. So or maybe I'll do with K. It's easier to say K drive. Okay. Click next. As soon as you click mount, as soon as you do it, you will see it have assigned. Now it's asking for the password. Remember the password I made? So I'll type the password here. Okay. All right. Now my container is mounted on my system. I can see this. How? Simple. Go in your files. You see a local disk K is created now. Now this is your secret disk. You will see if I open it, if I am in my this PC over here, I can see the local disk K. If in VeraCrypt, I will dismount it, if I dismount, the local disk K will vanish. See, it's gone. You see that? So it will only be available when I mount it with a proper password. So it's like a secret disk for me. So if you and me are using, okay, let's say if you and I are using both VeraCrypt, I'll create some data that I only want to be shared with you guys, and I don't want anyone else to be able to ever be able to see it. So I will create a container just like testing.txt is my container. It's it's like a hidden thing behind the texting file. There are some more data to it, maybe like a couple of documents or some signatures or stuff like that. And I'll share you the container file. I'll send it to you maybe via email or Google Drive or whatever. You will only be able to see the container if you know my password. That because when you will mount on your VeraCrypt, it will ask you the password, and when you put the password, you will be able to see the content after mounting it. You see, I open, I'm able to access how much? Almost 20 MB, as I mentioned earlier, 19.6 MB. So it's almost 20 MB here that I have available. I can store whatever I want. I can share it with whoever I want. And when they want to use it, they will be adding the same key, which is my password, in order to access the content. Otherwise, if I open, okay, if I try to open the testing.txt, see what happens. If I try to open it, it opens like this. Cannot access because it's being opened by other process. It basically shows like the file is maybe corrupted or inaccessible. So this way nobody will be able to figure out that what exactly is this file about, because it's not opening at all. And if I'm able to use it somewhere else, then obviously it's good, right? If I dismount the file right now, and if I try to open it again, see what happens. Ultimately, it will show an error or it won't open. That's what happened. This will be unresponsive or it will show corrupted, but only the people who have the proper information, that is a VeraCrypt container, and they will only be able to open it along with a proper password. So isn't that interesting that you can only understand what kind of file it is, and only the people you trust who are also a VeraCrypt user, they can access it, right? This is more interesting way of sharing data even more securely. This ensures like nobody will be able to, you know, see what you're sending in between. Even if the hacker have the container, without the password, he can't do anything with the container. So that's one way of using. That is one of the most efficient way of using VeraCrypt, by creating a container and mounting and using it. Simple to do stuff. There's one more example actually I want to give you. Just a second. See, hashing, when you go in depth, there is a lot of stuff in it. There is a concept of something we call as crypt analysis, where we analyze different cryptographic functions. It will be really deep topic and it will be really complex for you because you still don't know a lot about hashing. You don't know various kind of hashing functions and what are their mathematical importance, all that. So as of now, I'm not going into that depth. But I'm trying to give you as much information on the baseline as possible. Okay. Just like VeraCrypt is used for like containers designing and stuff, there's another tool called BitLocker. I don't know if you have heard of this before. BitLocker is also a tool which is used for encrypting your disk. You can simply look, you can also install it. It's free for usage. I will also share the file in my drive. When you install it, you will be able to find this kind of a tool available, Manage BitLocker. Let me open this thing. Okay. So you simply open this thing, manage BitLocker, this kind of stuff will come up. So I have two drives, drive C and drive E. So I can turn on BitLocker on either one of them. Let's say I want to do it on drive E. Okay, I'll click on turn on BitLocker, starting BitLocker. Use a password to unlock the drive. Okay, fair enough. I'll use a password. Let's say I type Holland 007 star A. Holland 007 star A. Okay, fair enough. Simple password. I'll click next. How do you want to back up your recovery key? I'll save it to a file and I'll save it on my desktop. I'll show you what this recovery key looks like. I'll save it here and click next. Okay, how do you want to encrypt it? Do you want to encrypt the disk space only or encrypt the entire drive? So let's say on my E drive, if you will see here, only 29 GB is occupied, is used. So it's asking me if you only want to encrypt 29 GB of use space or you want to encrypt the whole 39 GB. So I would like to go for the whole thing. I'll click next. Which encryption mode you want to use? You want to use a new one or a compatible one? So if you have a fixed drive, like a drive that is in your own system, in your laptop inbuilt, use a new encryption mode. Otherwise, if you have a external hard drive, use a compatible mode because external hard drives may have different file formats. So you should be using the compatible one. Otherwise, for the disk that are fixed in your system, you can use the first one and click next. Are you ready? And yes, I am ready. Start encrypting and let's see how it goes. Encryption in progress. If I click on this notification, I can see the encryption progress here. Let's wait for it to complete. And once it is done, we'll see what kind of changes we have now in my E drive. Oh, sincere apologies, guys. Let me just take a look at some configuration. Something went wrong. The lab is launching, so please wait. Just a few more seconds. Okay, here we have it again. Let's give it another try. Okay, it's almost 78% done. So just a few more minutes, I guess, and we'll have it. By the way, BitLocker is one of the best way to save your data. All I have, I think 6 or 7 hard drives, and they all are encrypted. And this is actually encryption makes it more. It makes it more secure, although it will be a little bit slower in when it comes to data transfer. But trust me, encryption makes it much better to save your file. The file will never get corrupted, will never get lost. Even if it get lost, the recovery is very easy. So that ensures the availability and the integrity of your file. So always keep your drives encrypted. Maybe try with a pen drive first, and if it is comfortable with you, then maybe you can go for a complete hard disk. So yeah, BitLocker is the one of the best software for encrypting the complete drive. To create a secret virtual drive, we use VeraCrypt. To encrypt the whole hard drive or a pen drive or something, use BitLocker. I always keep my important documents like degrees, certificates, and documents like government documents in a pen drive, which is BitLocker encrypted. So every time I want to use it, know which one I have, and I simply use it. So that can be your use case scenario for your organizations also. So this is a better practice. All right, here it says encryption is complete. Great job, BitLocker. We have an option to back up our recovery key, change the password, remove password, add a smart card. So there are smart cards as well, which is a whole different technology. We talk about like RFID and NFC. Let's not talk about those things as of now. Turn on auto unlock and turn off BitLocker. But I don't want to turn it off. Now, if I go in my drive, in my PC, this PC, you can see I have volume E. And if I try open it, everything is encrypted now. Everything is usable, you can see. But as soon as I try opening a folder or something, and if I try to, maybe let's say I want to rename it, I can do that. Oh, hold on a second. Okay, just a second. Let me reboot my system for a while. Okay, after the encryption, the drive will be available to you, of course. But after you reboot it once to implement all the changes that you just made, I mean, in terms of encryption, of course. Let's see what do we get. Okay, let's go in my file manager over here. And you can see the E drive is currently locked. So that is the best part about BitLocker. It will lock your drive until you want to open it again. So if I make a double click, the first thing it asks me is the key. That provide me the key, then only you will be able to access the drive. Otherwise, the drive is locked. You can make certain partitions where you want to keep some, secret documents. Right. So I can put the password, which was, I think, testing. I don't remember the password, frankly. Oh, okay. The password was password, so I forgot that. All right. So yeah, here we go. I'm able to access the files again because I just put in the password. In case you forget the password, and if in case you're not able to remember it ever again, what you can do is remember when I created a recovery key as well. Here is my recovery key that says BitLocker recovery key available. When I open it, to verify this is recovery key, compare the start of the following identifier, whatever, doesn't matter. When you will click forget password, it will ask you for this recovery key, and when you provide it, then only it will allow you to change password, otherwise it will not. So this is how BitLocker will work for you. Questions are coming in. Just a curiosity on DigiLocker location where you keep our document. So in India, we have this thing called DigiLocker, which is like a government provided cloud drive where you can upload your documents. Frankly, I do not trust on literally anything. Even Google Drive, I'm using just for the sake of distributing study material, but I don't really use Google Drive. I have my own server at home. I use them, but I can't give you access to my own server. That's why I shared you on Google Drive. But yes, drives are good. DigiLocker is also good enough. It's a good effort by the government. And to a very, very, very greater extent, they say that and claim that it's very safe. I personally have no experience with it, so I really cannot recommend it. But again, if you want, you can give it a try by yourself. DigiLocker is good enough in case of urgencies where you have no option left but to use it. If in case the government makes it mandatory, then I mean you cannot escape it, right? So yeah, that's what I have my take on it. Also, everyone, I am open for questions. We are done with the topic of cryptography for today. We have seen a lot of new tools, a lot of new concepts that you understood, different types of cryptography, different between a hash and a salt and a ciphertext, right? We understood a lot of processes too. So that was the end for today's session. The final session, by the way, I don't want you to go into the depth of it because it will be unfair with people who have no background of cryptography, and a lot of in-depth will require me to teach you more context. So I just kept it fundamental and basic so you know the concept of cryptography and a few more tools. So that was all for today. And here we have successfully finished the 15-day journey of learning cybersecurity more and more. I tried to deliver as much as I possible in the 15-day, 2-hour each day time. I am very sure I'm hoping actually you guys learned and enjoyed these sessions. And for the past 3 days, I haven't been opening my camera. I'm so sorry for that, by the way, for those who are complaining. And yeah, I am just glad I was able to help you out, guys, and give you more knowledge and learnings. If you guys were happy enough, please give a good feedback to the team also. It helps me to understand how I can, improve. Uh, I cannot provide my like direct contact details like my email or my WhatsApp or stuff like that, but I can definitely give you my LinkedIn. You can feel free to ping me anytime on my LinkedIn. I am available most of the time there. You can connect with me and yeah, we can have a professional connection there. I'll be sharing my LinkedIn again in my in the chat box. You guys can send me a connection request. I'll connect immediately, no problem. Also, Sunita is asking any research topic if I can suggest in security domain. So just like Okay, just to give you an idea, this will help you, improve your research skills also. Just like IDS and IPS that I told you about, like intrusion detection system and intrusion prevention system, there is a topic which is called as honeypots. Honeypots are, dummy servers. It's like I have a main server which is server A, which is having all my important detail. But what I will design my infrastructure, my technology infrastructure in such a way that if a hacker comes in, instead of being able to access A directly, he will always be redirected to server X, which is a dummy server. Even if he goes and hack the server, I don't care, right? So there are certain evasion techniques. We call them evasion techniques. So if you really want to search on these, if you want to do a research, you can do a research on honeypots, different type of honeypots and different type of evasion techniques. This will give you a new perspective on how more efficiently security can be implemented. And it will also give you a perspective that how tricky methods hackers can come up with. So this is a good research topic. I think it will be good. Or if you really want for your college students, or if you are a college student, if you want to make something good with the cybersecurity knowledge, start researching on IDS, IPS. These are like a base level firewall systems for on your web servers and on your computers. Look into this tool called Snort. Look into this tool called OSSec. These are the two very basic IDS and IPS tools available. They are very simple to use, frankly. Very simple manuals are available. I'll upload some videos on these two topics on my drive also very soon. Please stay updated. Yeah, I'll also create a document on my drive where I'll keep on adding newer and newer updates so that you are also familiar with whatever new things I'm adding. So yeah, that's also something I'll do later. Yes, Sunita, there are a lot of work available, but if you really want something unique, then definitely you have to search. I mean, there are so many topics that I can talk about right now, but again, we have a limitation of time, and then again, it's not something that will be fair with other people. Maybe you can connect with me on LinkedIn, and maybe we'll have a discussion over there. Right? I like to have a one-on-one talk on this. No problem. Is any idea about IoT research? Of course, IoT can be a good topic as well. If you have a good hold over the Arduino programming, then I think I can suggest you some really good topics. Right. I'm giving you the drive link in the chat box one more time, everyone. Please save this link, bookmark it, whatever you want to do. There is my drive link in the terabyte. I'm sorry, in the chat box. This is how it looks like. If you want some additional material to be added in the drive, when you open the link, you will see this contact the drive admin. When you open this document, there is a simple form that you can fill. Whatever kind of content you want, you can simply put the details in this form, and I'll make sure I'll be able to arrange and add that content in here. So yeah, that's one thing for you guys. You can also request content if you like. Also, the feedback link and the attendance link for today's session is also being added in this comment section. You can fill your feedback and attendance. And now that we have a lot of time remaining in our hands, let's discuss any doubts. If you have any doubts, queries, questions, confusions from any of the sessions in the past 15 days, let me know. This is the right time for you guys. You can ask. And I'm literally entertaining all kind of questions. Okay, this guy also asked me, where's the question? Can I suggest any secure method while I can keep around more than 150 certificates intact and secure? Okay, there are many other ways. Maybe you can use digital backups, do password management. Also, you can do cloud storages. Encrypted cloud storage are also available. There is an encrypted one that I also prefer to use sometimes. It's called Mega. Mega is also a cloud drive. It's also a very good one and very secure so far. You can use that. So yeah, these are some of the ways I think. No problem. You're welcome, Pooja. Thank you so much. Any other questions, guys? I'm waiting for you. Any questions, any queries, anything you would like to add or confirm? Okay, so Sheetal is asking, if data is in encrypted form, while tampering it, how hackers are working. So, Sheetal, let's just assume that this is your encrypted format. Like my name was Akash, right? My name is Akash. I'm sorry. And after the encryption of X plus 2, it becomes something like CMC. I think STUHIJ. CMCUJ, right? This is what it becomes after the X plus 2 encryption. Now, if hackers are going to tamper it, either they should know the encryption, right? Otherwise, there are certain tools that can also be used to brute force the hashes or ciphertext. This is called hash brute force. Now, this is a very advanced level of brute force that involves certain kind of techniques like rainbow table techniques. And here we talk about a lot of mathematical functionalities, and it requires a very good understanding of different hash functions. So it, because it will be beyond the scope of the session, that is why I didn't really came on to that part. But yes, there is they can basically either brute force, or they can either try to find what kind of encryption is being used. So that's one way of approach. Kalpana says, I'm a faculty. What advantage would I get if I complete my CEH V12? How do I renew it? So CEH V12 is one of the most basic and the most fundamental level certification that you can opt for if you're really willing to, get into cybersecurity. What I believe personally, people are underrating CEH very much by just saying that it's fundamentals. But trust me when I say this, there's a lot in CEH in terms of theory, in terms of concept that needs to be understood. Cybersecurity is not all about practical, not all about writing some random stuff on the keyboard. It's also about how much deeper you understand the concept. And if you have done CEH, trust me, if you have like diligently gone through the whole curriculum, you will get the complete idea of at least the baseline cybersecurity domain. Next, definitely to level up, you would have to get new skills, but CEH is one of the best stepping stone for you guys. So if you want to go for it, I mean, as a faculty also, if you are maybe, I'm not sure what kind of faculty, if you're working in a corporate sector or maybe in a college or something, if you are into teaching line, definitely it will give you a good, a baseline idea of what to teach and how to teach, because it will be making you the clarity. It will give you the clarity of the topic. In addition, if you are working professional, then definitely it will add up to your profile. So yeah. And the renewal process, I think it's now 2 years. I think in 2 or 3 years you can get it renewed. I think it's 3 years now. Earlier it was 2 years. So yeah, every 2 years you can get the certificate renewed. So that's how it is. Sure, Afridi, you can connect with me on LinkedIn, no problem. I'll be glad to assist you with the OSCP part. Thank you so much, Santesh, for your kind words. I really appreciate them. Thank you. Okay, for those who are really willing to know about more certification, I'm going to tell them right now. There are few very modern certifications. I mean, the latest certifications, the ones that are trending. One of them is by the EC Council, which is CEH V12, the version 12. Go for that. Either go for this, or there is with CompTIA, which is Security Plus. Go for this. These will be for those who are starting in this domain. I mean, who are just like beginners. Who are a little bit more advanced, they can go for ECSA from EC Council, or in CompTIA there is CISA Plus. You can go for that also. Those who are like having a little bit of experience, who have a really good experience, they can go for certifications by offensive security. The certifications are like OSCP, OSWP. There is also OS, I think IE. OSCE, right? Sorry. I have OSCP and OSWP. OSCE, I'm still like going to prepare. But also there is another organization called ISC Square. This, as of now, you can refrain from, but I think these many certifications will be good enough for a beginner. Okay, Kalpana is asking for a basic level certification we should do to land the first job. Okay, it will be funny for me because I landed my first job without any certification. But yes, it is a good thing to have certifications. If you really want to get one to begin with, go for CEH V12. Nothing better than this. It is very relevant. A lot of people, a lot of companies appreciate this one. Very baseline, basic certification they ask for is CEH V12. This is a basic standard. Later on, if you want, you can also add Security Plus. It will just, enhance your resume. So these two are one of the ones that I always recommend to people. Later on, you can definitely add more and more. If somebody is also looking into build a good profile, a strong profile, try going for a Cisco certification in CCNA. The advanced version of CCNA is CCIE, which is especially CC. If you're going CCIE, go in CCIE cybersecurity. There's like different variations in CCIE. So CCNA is all about, the full form is Cisco Certified Network Analyst. So that is the certification for people who are good with networking. They teach you like the complete configuration and the communication part of it. So I think it will be a good refresher for you guys to learn networking properly. So yeah, you can also go for this one to build a more stronger profile. In addition to these certificates, you can literally go on any certification website, look for free certificates, keep getting more and more relevancy because they will add up to your resume. If I talk about free certifications in my beginning days, I might have more than 70 of them. But my point is, it's important to get the most relevant ones, which are these. And then later on, you can add as much as you want. Doesn't matter. Free certificates also give you good relevancy because they help you build a skill. It gives you experience, right? The paid certificates are kind of like, it's an honor that it's a confirmation that you went through an examination process. There was a complete evaluation that you went through. And that is when you get this certificate of confirmation. So that's the difference between a paid and a free one. Both of them are good. Go for either one of them, doesn't matter. You can also land a job with free certificates also, frankly. Rakib says, I'm also interested in data analytics, but is it useful to do this course? They are two different, very, very different things, actually, Rakib. It's almost like potatoes and oranges, like data analytics is like completely all about, talking about big data or different vectors of analysis. So it's nothing to related with cybersecurity, frankly. Okay, Xenia says, I heard Google cybersecurity courses give you discount voucher for Security Plus. Is it worth starting with that instead? The Google certificate is free, but it requires Coursera Plus, which costs a little less than 5,000. Okay, Xenia. Dear. You know what? Instead of this Google certificate or that, I see frankly, Xenia, it sounds to me like a marketing gimmick. They are making you buy the Coursera Plus certification, which is like, for me, it doesn't really make sense. But you can go for the Microsoft Azure certification also. I think it's AZ 300 or AZ 100. I'm not sure about that. So this is like the base level certification in Microsoft. They also teaches you the same thing, and it's cost even less than 5,000. It's almost like, I think it's 3,200 bucks, 3,200 INR. 32 was 3,600 INR. I'm not sure what's the price these days. In my days, it was like almost 3,000, but I don't know how much it is now. So this is like a base level certification that you can also go for AC 100. So yeah, instead of that, this one holds a little bit more relevancy. So you can go for that too. So yeah, I think these are the important details. Also, for anyone who is interested to know more about these certificates or any other certificates for that matter, I'm not endorsing, but you can go on my LinkedIn profile, watch all my certificates, see what I have, and maybe you can also apply for those as well. I have a lot of certificates from various organizations. I'm not bragging about it again, but it's important that to for a reference you can go through that if you really need it. All right then, I think that was all for our final session here. I am so glad I was able to help you all guys, and I wish you all the very best ahead. Please mark my words. Stay safe on the internet. Take care of yourself. Stay hydrated and keep learning. This is your trainer Akash Sharma. This is our final day. Thank you so much, everyone. I wish you good luck. Keep learning. Yeah, back to the ExcelR team. Bye for now.
Yeah, sure. Thank you so much, Akash, for such a wonderful sessions and making this program successful.
You're welcome,
So,
Amar.
yeah, my dear participant, I already shared the today's attendance link in the chat box. So please mark your attendance and share your valuable feedback. I'm going to share the attendance link once again in the chat box, and I will explain you regarding to the certificate. So just give me a moment to share the attendance link. Okay, so coming to the certification part, so those who attended 60 and more than 60% of the session, they will receive the certificate within 7 to 8 working days via their registered email ID. Okay, I will repeat once again. So my dear participants, those who attended 60 and more than 60% of the session and they mark their attendance on a daily basis, definitely they will receive their certificate via registered email ID within 7 to 8 working days. Okay. So after 7 8 days, if you feel that I not received the certificate, I did my attendance on a daily basis, I marked my attendance, I attended all the sessions. So in such situation, drop an email to edl@excelr.com. My team will check your attendance and they will get back to you what is your attendance percent. Okay. I hope it's clear. Going forward, if you need any help from EDL or ExcelR team, definitely you can reach out to the edl@excelr.com email ID. Our team will connect with you. Okay. If you have any query or question, just please let me know. Feedback link. Okay, I'm sharing the feedback link. So there is one question from Pooja. How long FDP data available on ExcelR website? So participants, the recorded sessions and whatever the material we uploaded over the LMS, that will be with you for lifetime. You can access that anytime. Okay. There is no any such kind of expiry. Anything else, to participants? Okay, great. Then once again, thank you so much, all of you, for making this session successful. And we'll again see you in the next FDPs. Thank you so much. Bye bye. Have a nice day. and all the best for your future endeavors as well.